Hello everyone, and welcome to the exercise on object-oriented programming. Here are the instructions for the exercise. Let's go through the instructions. It says write a program called a fraction which accepts attributes numerator and denominator and returns a string representation of a fraction. You will need two methods that will get the numerator and denominator. You will also need two methods that will set the numerator and denominator. Don't forget to check the denominator, and it cannot be 0. So we can have an if-else statement to check for this condition. And finally, try to include a one-line docstring for your class and the methods involved. So this is just a program to see if a number is a fraction. Fraction means a rational number. So the numerator can be any integer, whereas the denominator cannot be 0. So try the exercise, take a moment, and then we'll see the solution together. Great, let's see the solution together. Let's start by defining our class. So class, we'll call it a fraction. And let's add some docstring to our class. Our class represents a fraction. And then we have our first method, the init method. Let's define our init method. It accepts self as its first parameter, and as the instruction says, it accepts two parameters, numerator and denominator. So if I go back here, it accepts two attributes or parameters, numerator and denominator. Okay, and it says we'll need two methods that will get the numerator and denominator. So let's initialize our attributes numerator and denominator. We can say self that, let's say numerator, self that numerator is equal to num. So we'll have a separate function that will get the numerator, and once we get the numerator using that method, we'll set it to be equal to the numerator. So self that numerator is equal to numerator, and for our denominator we need to check that it's not equal to 0. We can say if our denominator is not equal to 0, or if it's different from 0, so not equal to 0, we can say self that denominator is equal to denom. Again, we'll also have a separate method that will set the denominator. Or else, we can print a message like there was an error with your calculation, and we can exit the program. In such case, I will show you a trick. There is a module called sys. So from sys, we'll import exit, and then we'll simply exit. So in case a user enters 0 for denominator, our program will be exited. That's what this does. From system import exit, and we'll simply exit and close out the program, so we won't get an error. Great. Next we have, it says here, you will need two methods that will get the denominator and numerator. Let's define those two functions, those two methods. So the first one, define, we can say get numerator, and then it accepts self as its parameter or argument, and this will simply return the numerator. So we can say return self dot numerator. We can initialize it also. We can say, let's say, this will return the numerator. Okay, we can say that, and then it will return the numerator so that we can use it in our init method. And similarly, let's define another method that will return the denominator. So define get denominator, and then it accepts self as its attribute, and this method will simply return the denominator. Let's initialize it. This will return the denominator. And it will simply return self dot denominator. Great. Next we will also need two methods that will set the numerator and denominator. Okay, let's define our first function, our first method. So let's define our method. Define, let's call it set numerator, and then it will accept self as an attribute and also a numerator. Let's call it nu for numerator. Basically, when a user enters a numerator, we'll use this method to set the numerator, and once we set that numerator, we can use it using the get denominator, which we will later use in our init method. Okay, so this, let's initialize our attribute numerator nu. Before that, let's include a doc string. We can say this will set the numerator or something like that. Okay, so self dot numerator is equal to nu for numerator. Similarly, we'll have another method called set denominator, and it accepts self and a second attribute. Let's call it de for denominator. You can name it whatever you like. Let's include a doc string. This will set the denominator, and the denominator cannot be 0, right? So this will set the denominator. If denominator is equal to 0, it will terminate the program or exit the program. Terminate and exit the program. That should be good. Now let's initialize our attribute de. We can say if our denominator is different from 0, if it's not equal to 0, we can say self dot denominator is equal to DE, or else we need to terminate the program. So same thing that we did here. Or else we can print, let's say, denominator cannot be 0. And let's import sys module, and then we'll import the exit function, and we'll simply exit the program in case the denominator is 0. Okay, that should be good. And finally we have, don't forget to, okay, we did that. Try to include a nice and short one line. We did that also. And we are missing, okay, here it says return a string representation of our fraction. So what we'll do is we'll use the str method. Let's define that so that we get a nice string representation of our fraction. Okay, define underscore underscore str underscore underscore, and it will take self as its attribute or parameter. Okay, let's include a dark string. This will return a string representation of our fraction. That should be good. And this will simply return a string representation of our. So in this case, what's important is we'll have our numerator. So we'll use this function to get our numerator, and we'll divide it by our denominator, which we get by using the get denominator function. So that will be our fraction, right? Denominator divided by the numerator divided by denominator. So we'll have our self that get numerator. The reason I'm casting it as a string is because this is an integer, so we need to cast it to a string. So we have that. So this method will return our numerator. It will get our numerator and then convert it to a string. So we have that plus divided by, and we'll do the same thing for our denominator. Once we get it, we'll cast it into a string. So self that get denominator, right? And then we can, so to make it nice, we'll define the main function, define main, and we'll place all the things we want to do in the main function. And later we can call this main function and it will execute all the things that we want. Okay, so let's initialize an instance of our fraction class. Let's say fraction1, and we'll save the first instance in this variable fraction1, and we'll set it to be equal to fraction, and let's try 2 and 7. Okay, and then let's have another instance called fraction2. Let's say fraction, and then 3 and 8. Okay, and then we can print, now let's print underneath each of them, print fraction1, and here we can print fraction2, and before that let's print now we will change the numerator and denominator to different numbers and then see the result. Okay, we can say fraction 1 dot set the numerator. So initially it was 2. Now let's make it 9. So we'll set the numerator to 9, and let's do the same thing for our denominator. So fraction 1 dot set denominator, and let's set it to 19. Then we can print fraction 1 now. Then let's print some lines in between, say times 10. And next we'll call our main function and see the result. I'll go over our program one more time and explain what each of the methods do. Let me run it first. Okay, 2 over 7. Now we'll change the numerator and denominator to different numbers. We have 9 over 19, 3 over 8. Good. It works good. Now let me go over our program. So we have our fraction class, and then our class represents a fraction. We have our init method. It accepts 2 attributes here, numerator, num, and denominator. And we initialize the denominator and numerator attributes. Self.numerator is equal to num, and then we have self.denominator is equal to denominator. Okay, and here we have an if-else condition to check if the denominator is not 0. If the denominator is 0, we use this to exit our program. Okay, from sys import exit. So this will exit the program in case our denominator is set to 0. And the self.numerator and self.numerator, denominator and numerator, we have separate methods to get those values. And once we get those values using the get numerator and get denominator, we use them in our init method. So we have our get numerator method, which will simply return the numerator of our class. And we have the get denominator method, which will simply return the denominator. And we have this set numerator and set denominator methods. So those methods will set the numerator and denominator respectively. So this is in case the user enters a numerator. So let's say the user enters some numerator, let's say 10. So it will set, this method will set the numerator to 10, and then so that our get method can get that, our get numerator method can get that numerator. So user inputs, we have this method set numerator, and the get numerator method will get that numerator from this method, and then later on it will be used by our init method. And that's what the set numerator does. It does the same thing for denominator, and it also checks that the denominator is not 0. In case the denominator is 0, it will exit the program. And finally we have our special str method, which returns a nice string representation of our fraction. So it returns a string representation of our get numerator method divided by a string representation of our get denominator function. So numerator divided by denominator. That's why you see here a nice string representation. Okay, and we put everything we want to do in this main method. So later on, by simply calling the main method, we are able to execute all of this instead of typing one by one, initializing the class, typing one by one. We can simply call the main method. Okay, and in the next lecture we'll continue with what we have here. We'll briefly explain this main method and what each of these codes do. Thank you everyone, and see you at the next lecture.